How does the Crew Dragon spacecraft work? SpaceX, it was late at night. Inside a quiet control room, dozens of screens were glowing. Engineers were sitting still, watching numbers move on the screens. No one was talking, everyone was waiting. This was not just another space mission. This was a desperate call for a new future. For many years, humans depended on old technology to go to space. After the space shuttle program ended, something shocking happened. The United States could no longer send its own astronauts into space. They had to ask for help. They had to buy seats from another country. This was a hard moment for space history. NASA needed a solution, and they needed it fast, so NASA made a call, not to a government company, not to an old space giant. They called a private company. Its name was SpaceX. At that time, many people laughed at this idea. They said, a private company cannot send humans to space. They said, this is too risky. They said this will never work, but SpaceX did not stop. The company was started by a man with a bold dream. He wanted to make space travel cheaper, safer, and reusable. He believed that humans must become a spacefaring species. NASA gave SpaceX a challenge. Build a spacecraft, they said, one that can carry humans, one that is safe, one that can fly to the International Space Station, and bring astronauts back alive. This was not a simple request, this was a desperate call. SpaceX accepted, and this is where the story of Crew Dragon begins. Crew Dragon was not built like old spacecraft. Older capsules were simple, they had many buttons, many switches, they needed a lot of manual control. Crew Dragon was different. From the beginning, SpaceX wanted something new, something modern, something smart. They wanted a spacecraft that could think, a spacecraft that could fly itself. Many engineers worked day and night. They designed, they tested, they failed, they tried again, mistakes happened, explosions happened, but they did not stop, because failure was part of the mission. Crew Dragon slowly took shape. From the outside it looked smooth and clean, it had a simple shape, no sharp edges, no complex parts visible, but inside it was powerful, very powerful. NASA watched every step, every wire, every line of code, every small change, because this time human lives were at risk. One small error could mean death, pressure was high, time was running out. The International Space Station was always above Earth. Astronauts were living there, they needed supplies, they needed crew rotation. NASA could not wait forever. Crew Dragon had to work, then came the test missions. First, SpaceX tested Crew Dragon without humans. The spacecraft launched into space. It flew around Earth, it docked with the space station by itself. No pilot, no human control, everything was automatic. When it returned safely, something changed. People started to believe, but belief was not enough. NASA needed proof, real proof. Then came the biggest test, a mission with humans, 2 astronauts. They trusted their lives to Crew Dragon. This moment was historic. For the first time, a private spacecraft was going to carry humans into space. The world was watching. Launch day arrived. The rocket stood tall on the launch pad. Crew Dragon sat on top, quiet and ready. Inside the capsule, astronauts were seated. They were calm, they were trained, but deep inside they knew the risk. Everyone knew. The countdown began. 10, 9, 8. Engines started. Fire and smoke filled the air. The rocket lifted off. Crew Dragon was flying. But this documentary is not about that launch. Not yet. This story is about how Crew Dragon works, because sending humans to space is not magic. It is engineering, it is science, it is design, and it all starts with one question: why was Crew Dragon needed? After the space shuttle was retired, NASA lost its ride to space. For almost 10 years, astronauts depended on Russian spacecraft. This was expensive. This was risky. This was not a long-term solution. NASA wanted independence again. They wanted a new system, a system that could be used again and again, a system that was safe. Crew Dragon was the answer. Crew Dragon was built to be reusable. Old capsules were used once, then they were thrown away. Crew Dragon could fly multiple times. This reduced cost. This saved time, but reuse was not the only goal. Safety was the main goal. Crew Dragon was designed with escape systems. If something went wrong during launch, capsule could separate, it could fly away from danger. This system saved lives. Inside Crew Dragon, things looked different. There were no hundreds of buttons, no confusing switches. Instead, there were screens, touch screens. Astronauts could control the spacecraft by touching the screen. This was new. Some people were scared. What if the screen failed? They asked. SpaceX had an answer: backup systems, manual controls, multiple computers. If one fails, another takes over. Crew Dragon was built to survive failure. Another big change was automation. Crew Dragon can fly itself, it can dock itself, it can return to Earth by itself. Astronauts are there to monitor, to help if needed, but the spacecraft does most of the work. This reduces human error, this increases safety, but building such a system was not easy. Every line of software was tested, again and again. Thousands of simulations were run. Worst-case scenarios were imagined. Fire, loss of power, loss of communication. Crew Dragon had to survive them all. One of the most important parts of Crew Dragon is trust. Trust between astronauts and machine. Trust between NASA and SpaceX. Trust between humans and technology. Without trust, Crew Dragon would never fly. As Crew Dragon missions continued, confidence grew. The spacecraft worked again and again. It carried astronauts safely. It returned them home. Something had changed in space travel. The desperate call had been answered, but the story was just beginning, because understanding Crew Dragon means understanding its design, its structure, its systems, and how all parts work together as one. In the next part, the journey goes deeper, inside the spacecraft, inside its body, inside its design, because what looks simple from outside is actually one of the most advanced machines ever built. And this machine carries humans hundreds of kilometers above Earth, into the darkness of space. End of part 1, but to truly understand Crew Dragon, we must step inside the spacecraft itself. To be continued. The hidden world inside Crew Dragon. The spacecraft looked calm. From the outside, Crew Dragon appeared silent and still. No moving parts, no noise, just a smooth white capsule floating in space. But inside it was alive. Very alive. Thousands of systems were working at the same time. Electric signals were moving faster than human thoughts. Computers were making decisions every second. Crew Dragon was not sleeping, it was watching everything. When astronauts enter Crew Dragon, the first thing they notice is silence. No loud engines, no shaking walls, just a soft hum. This silence is important. In space, sound does not travel. So Crew Dragon was designed to feel calm, because calm keeps astronauts focused. The inside of Crew Dragon does not look like old spacecraft. There are no long rows of switches, no complex control panels. Instead, there are 4 large touchscreens. These screens are the heart of the spacecraft. They show speed, they show direction, they show fuel levels, they show warnings. Everything is simple, everything is clear. SpaceX wanted astronauts to feel comfortable. The seats are shaped to support the human body. They reduce stress during launch and landing. Each seat is custom made. No 2 astronauts sit the same way. This small detail matters, because in space, comfort means safety. Behind the screens, something more powerful is working. Crew Dragon uses multiple computers, not 1, not 2, many. These computers constantly check each other. If one makes a mistake, another corrects it. If one fails, another takes control. This system is called redundancy. It is one of the reasons Crew Dragon is so safe. Crew Dragon does not trust a single brain, it trusts teamwork. The spacecraft also has sensors everywhere. Sensors check temperature, sensors check pressure, sensors check air quality. If something changes, Crew Dragon knows immediately. Astronauts get alerts, ground control gets data. Nothing is hidden, nothing is ignored. Air inside Crew Dragon is carefully controlled. Oxygen levels are balanced. Carbon dioxide is removed. The air feels normal. This is important, because in space, one mistake with air can be deadly. Crew Dragon treats air like gold. Lighting inside the spacecraft is also special. The lights change color. Blue light helps astronauts stay awake. Soft light helps them rest. This helps control sleep cycles. In space, there is no day or night. Crew Dragon creates its own time, but the most impressive part is control. Crew Dragon can be controlled in 3 ways. First, automatic control. The spacecraft flies itself. Second, manual control. Astronauts can take over using touchscreens. Third, ground control. Engineers on Earth can help if needed. This triple system makes Crew Dragon very flexible. During most missions, astronauts do not touch anything. They watch. They monitor. Crew Dragon does the work. It adjusts speed. It changes direction. It prepares for docking. All by itself. But what if something goes wrong? SpaceX planned for that too. Crew Dragon has emergency modes. If pressure drops, it seals sections. If power fails, backup batteries turn on. If communication is lost, it follows pre-planned commands. Crew Dragon does not panic. It follows logic. One of the most important systems is communication. Crew Dragon talks to Earth all the time. It sends data. It receives instructions. Even when astronauts sleep, communication continues. If the signal is lost for a moment, the spacecraft keeps flying safely. It does not depend on constant contact. Another hidden system is temperature control. Space is extreme. One side of the spacecraft faces the sun. The other faces deep cold. Crew Dragon balances heat using special materials and cooling systems. Without this, electronics would fail. Humans would not survive. Every wire inside Crew Dragon is tested many times. Every screw is checked. Nothing is random. Nothing is accidental. Before flying with humans, Crew Dragon was tested again and again. Engineers tested failures on purpose. They turned systems off. They cut power. They simulated damage. They wanted to see how Crew Dragon reacts. Most of the time, it solved problems by itself. When it could not, backup saved the mission. This level of testing builds confidence. Astronauts trust Crew Dragon because it has proven itself. Not once, but many times. Crew Dragon is not just a vehicle. It is a system. A system designed to protect life, but there is something even more important. Crew Dragon must survive launch. Launch is the most dangerous moment. Engines burn fuel violently, the rocket shakes, the pressure is extreme. Crew Dragon is built like a shield, strong, sealed, prepared. If the rocket fails during launch, Crew Dragon can escape. It uses powerful engines to pull itself away. This system works in seconds. It can save lives. This is not theory, it has been tested. Inside the capsule, astronauts trust the system. They know Crew Dragon is watching. They know it is ready. From the outside, Crew Dragon looks simple. From the inside, it is complex, but complexity is hidden so humans can focus. This is the future of space travel: less stress, more automation, more safety. But one question remains. How does Crew Dragon move in space? How does it turn? How does it slow down? How does it approach another object without crashing? That story begins with fire, small controlled fire, hidden engines, precise movement. In the next part, the mystery continues. We explore the engines, the thrusters, the silent pushes that move Crew Dragon through space. Because in space, even a small push can change everything. End of part 2. The machine is silent, but its power is always ready. To be continued. Space looks calm. From far away, everything seems still. The Earth slowly turns, stars do not move, but this calm is an illusion. In space, movement is constant, and movement must be controlled. This is where Crew Dragon shows its true power. On Earth, vehicles move using wheels. In the air, planes use wings, but in space there is nothing to push against. No road, no air. So how does Crew Dragon move? The answer is simple: fire, but not the fire people expect. Crew Dragon uses small engines called thrusters. They are not loud, they are not dramatic. Most of the time they are invisible, but these small engines decide everything. Each thruster produces a short burst of force, just a tiny push. In space, even a small push is powerful. 1 second of thrust can change speed, change direction, or stop motion. Crew Dragon uses this rule perfectly. The main engines used for movement are called Draco thrusters. They are placed all around the spacecraft. Top, bottom, sides. This allows Crew Dragon to move in any direction: forward, backward, up, down, left, right, even rotation. When Crew Dragon needs to turn, it does not steer like a car. Instead, one side pushes. The opposite side stays quiet. This creates rotation, slow, smooth, controlled. Nothing is sudden. Because sudden movement in space can be dangerous. Fuel is precious. Crew Dragon cannot waste it, so every movement is planned. Before a thruster fires, computers calculate everything: speed, mass, distance. Nothing is guessed. The fuel used by Draco thrusters is special. It is stored safely inside the spacecraft. 2 chemicals meet inside the engine. When they touch, they ignite. No spark needed. This makes the system reliable, simple, effective. Crew Dragon never fires thrusters randomly. Each burst has a purpose: to adjust orbit, to align with a target, to prepare for docking. Everything is precise. One of the most difficult tasks in space is slowing down. There is no air resistance. If you move, you keep moving. To stop, Crew Dragon must push in the opposite direction. This is called retrograde burn. It sounds complex, but the idea is simple: push back to slow down. When Crew Dragon approaches the International Space Station, this control becomes critical. The station is moving at high speed. Crew Dragon must match that speed. Too fast and it crashes, too slow and it drifts away. There is no second chance. Crew Dragon uses sensors to understand distance. Lasers, cameras, navigation systems. It sees the station, it measures movement, then it decides. Fire thruster, stop, wait, fire again. This process can take hours. Slow is safe. Fast is deadly. Astronauts watch everything, but they do not panic because Crew Dragon has done this before many times without humans. One of the most amazing features is automatic flight. Crew Dragon can move entirely on its own. It follows commands written before launch. If needed, it can change plans. It adapts. This is not just automation. This is intelligent, but automation does not mean no control. Astronauts can take over. Using touchscreens, they can fire thrusters manually. This is rarely needed, but it is there just in case. Movement in space also affects orientation. Which side faces Earth, which side faces the Sun? Crew Dragon controls this carefully. Solar exposure matters, communication matters, every angle is important, even small vibrations matter. Crew Dragon keeps movement smooth. Sudden motion can make astronauts sick. It can damage equipment, so thrusters fire gently, short bursts. Controlled power. There's another type of engine on Crew Dragon, more powerful, more dangerous. These are the SuperDraco engines. They are not for normal movement, they are for emergencies. If something goes wrong during launch, SuperDracos activate. They pull the capsule away from the rocket fast, very fast. This escape system can save lives. It has been tested, it works. But SuperDracos are silent during normal missions. They wait, always ready. Every movement Crew Dragon makes is recorded. Data is sent to Earth. Engineers study it. They learn, they improve. Each mission makes the system better. In space, mistakes travel far. Crew Dragon avoids mistakes by planning everything. Orbit changes are calculated days before. Thruster use is optimized. Nothing is wasted. The beauty of Crew Dragon movement is its invisibility. From outside you see nothing. No flames, no smoke, just slow motion. But inside, decisions are being made every second. This is how modern spacecraft travel. Quiet, precise, smart, but movement is only part of the story. Crew Dragon does not travel alone. It must meet another object in space. A massive one, a fragile one, the International Space Station. Approaching the station is one of the most dangerous moments. 2 objects moving at thousands of kilometers per hour. One small mistake, One wrong calculation, and everything is lost. Crew Dragon prepares for this moment carefully. It slows down, it aligns, it waits, then it moves again. Closer, closer. This moment requires perfect control, perfect timing, perfect trust in machines, and this leads to the next chapter. The moment when Crew Dragon must connect, lock, and become part of another world in space. In the next part, the tension rises, because docking is not just movement. It is precision at the highest level. It is silence, it is patience, it is trust. End of part 3. In space, power is not about strength, it is about control. To be continued. There is a moment in space when everything must slow down, not because time changes, but because one mistake can end everything. This moment is called docking. The International Space Station is huge. It is as big as a football field. It moves around Earth at extreme speed, faster than a bullet. Crew Dragon is much smaller. It is quiet, it is careful, it is patient. For docking to work, both must move as one. From Earth, docking looks easy. Two objects come close, they connect. But in space, docking is one of the hardest tasks ever created. There is no air, no friction, no second chance. Crew Dragon does not rush. Hours before docking, it begins to slow down. Thrusters fire gently, then stop, fire again, then wait. Every movement is measured. Every push is planned. The spacecraft does not rely on eyes. It relies on sensors. Lasers measure distance. Cameras track movement, computers calculate speed. Crew Dragon knows exactly where it is and where the station is. As it gets closer, tension rises. The distance becomes smaller, kilometers become meters, meters become centimeters. At this stage, speed is almost zero, almost. Astronauts sit quietly, they do not talk much. They watch the screens, they trust the system. But they are ready, just in case. Crew Dragon switches into docking mode. This mode changes everything. Movement becomes slower, decisions become stricter. Safety rules become tighter. Nothing is allowed without permission. The spacecraft now follows invisible paths. These paths are called approach corridors. If Crew Dragon leaves this path, it will automatically stop or move away. Safety comes first. Always. The station feels close now. So close that astronauts can see it through the window. Solar panels stretch across space. Metal structures shine in sunlight. It looks peaceful, but it is dangerous. Crew Dragon pauses. Yes, it stops. This is normal. The spacecraft waits at specific points. These are called hold points. Here, systems are checked. Data is reviewed. Everything must be perfect. Engineers on Earth are watching. Astronauts on the station are watching. Everyone is silent. Then permission is given. Crew Dragon moves again. Slow, very slow, slower than walking. At this distance, even breathing feels loud. The spacecraft is now closer than ever. The docking port is directly ahead. Crew Dragon aligns itself. Rotation stops. Angle adjusts. It must be perfect. A small misalignment can damage both vehicles. The final approach begins. This is the most dangerous part. There is no room to escape. No time to think. Everything depends on preparation. Crew Dragon moves forward, centimeter by centimeter. Thrusters fire in tiny bursts, almost invisible, almost silent. Then it happens. Contact, soft, gentle, not a crash, not a hit, a touch. Hooks inside the docking system activate. They pull the spacecraft closer. Slowly, carefully, metal meets metal. A sound is heard, a deep click, then another. The spacecraft is locked. Docking is complete. For a moment, no one moves. No one celebrates, because docking is not finished yet. Pressure checks begin. The seal must be perfect. No air leaks. No cracks. Life depends on this. Minutes pass. Systems confirm success. The seal is strong. The air is safe. Only then do people relax. Smiles appear, quiet ones. Crew Dragon has become part of the station. Two worlds connected. Hatches are still closed. They wait. Air pressure equalizes. This step cannot be rushed. Finally, the hatch opens. Astronauts float inside. A new chapter begins. But Crew Dragon does not sleep. Even while docked, it stays alert. Power flows. Systems monitor. Computers stay active. Crew Dragon is now a lifeboat. If something goes wrong on the station, astronauts can return home inside it. This responsibility is huge. For months, Crew Dragon waits, docked, quiet, ready. Every day it checks itself. Fuel levels, battery power, system health. Nothing is ignored. Station moves through sunrise and sunset. 16 times a day. Crew Dragon feels it all, heat, cold, but it remains stable. This is not just technology, this is trust. Docking is a dance, a slow dance between machine and machine, between Earth and space. Between danger and control. Many spacecraft have failed here. Some crashed, some missed their target, some never returned. Crew Dragon learned from all of them. It carries lessons written in code. Lessons written in metal. Lessons written in history. This is why docking matters. It is not just connection. It is survival, but docking is only half the journey. Because one day Crew Dragon must leave, and leaving is just as dangerous. Undocking means separation, letting go, moving away without impact, without damage, without mistakes. That story is coming. But before leaving, Crew Dragon must prepare for something even more violent, something unstoppable, returning to Earth. In the next part, fire returns, not small thrusters, but massive heat, burning plasma, a fall through the sky because space does not forgive and Earth does not welcome gently. End of part 4. In space, connection is fragile, precision is survival. Every mission in space has one truth: going up is dangerous, but coming back is worse, much worse. For days, Crew Dragon stays quiet. Docked to the International Space Station, it waits like a shadow. Astronauts float in the station. They work, they sleep, they laugh. But Crew Dragon never forgets its purpose. It is not just a visitor, it is a return ticket. One day the command comes, it is time to go home. This moment is never easy because space does not want to let go. Astronauts prepare slowly, tools are packed, experiments are closed, personal items are secured, nothing can float freely. Because during re-entry everything becomes heavy, very heavy. Crew Dragon is checked again and again. Fuel levels, heat shield status, parachute systems, computers, every system must be perfect. There is no repair shop in space. The hatch between the station and Crew Dragon closes, a soft sound, then silent. Two worlds are separated again, pressure checks begin, air leaks are deadly. Crew Dragon waits, the seal is strong, undocking starts, small hooks release, slowly, carefully. Crew Dragon moves away, not fast, never fast. The station grows smaller. Crew Dragon fires its thrusters, just enough to drift away. A safe distance is needed because the next step is dangerous. This step is called deorbit burn. It sounds simple, but it decides everything. Crew Dragon must slow down just a little, not too much, not too little. If it slows too much, it can fall too fast. If it slows too little, it can skip off Earth's atmosphere like a stone on water. Both are deadly. The computers calculate angle, speed, time. Earth is spinning below. The landing zone is moving. Everything must align. Then the engines fire, not violently, not dramatically, just long enough. This small burn changes destiny. Crew Dragon is no longer staying in orbit, it is coming home. As it approaches Earth, something strange happens. The sky begins to glow, not with light, but with heat. Air molecules hit the spacecraft at extreme speed, they compress, they heat up, they turn into plasma from the outside. Crew Dragon is surrounded by fire. A bright burning shield, temperatures rise above thousands of degrees. Hotter than lava, hotter than steel melting. Inside the capsule it is quiet, almost calm. This is the power of the heat shield. The heat shield is not just metal, it is a special material. It burns away on purpose, layer by layer, sacrificing itself to protect life inside. As it burns, it carries heat away. This is called ablative protection. Simple idea. Powerful result. Astronauts feel pressure. Their bodies become heavy. Gravity returns, not gently but suddenly. 3 times Earth gravity, 4 times. Breathing becomes harder, movement becomes slow. The capsule shakes, not violently, but enough to remind everyone this is real. Communication with Earth is lost. This is expected. Plasma blocks radio signals. For several minutes, Crew Dragon is alone. No voices, no instructions, only computers, only trust. This blackout is one of the most stressful moments. Because if something goes wrong now, no one can help. Crew Dragon continues. It does not panic. It follows its path. Slowly, the fire fades. The sky changes color. Blue appears, clouds form, Earth is close. At the right moment, the parachute system activates. First, small parachutes, they stabilize the capsule, they slow it down. Then the main parachutes deploy, huge, bright, powerful. The fall becomes gentle, almost peaceful. Below, the ocean waits. Crew Dragon hits the water, not hard, not soft, just right, a splash, then stillness. The capsule floats, it is alive. The mission is almost over, recovery teams move in. Boats approach, checks begin, the hatch opens, fresh air enters, astronauts smile. Not because they are heroes, but because they are home. Crew Dragon has done its job again, but this success is not luck. It is design. Every step was planned. Every risk was studied. Every failure was learned from. Old spacecraft were thrown away after landing. Crew Dragon is different. It is recovered, inspected, prepared again. This is the future, reusable, reliable, human-focused. But the story does not end here, because Crew Dragon is not just for Earth orbit. It is a test, a beginning. The lessons learned here will travel farther. To the moon, to Mars. Fire is not the enemy, fear is. And Crew Dragon was built to face both. In the next part, we look at what happens after landing. How Crew Dragon is reused, how it is prepared again, and how this changes space forever. End of part 5. Coming home is not the end of the journey, it is proof that the journey worked. To be continued. Why Crew Dragon is not a one-time machine. Most spacecraft end their journey in silence. They burn, they sink, they are forgotten. Crew Dragon is different, for it landing is not the end. It is only a pause. After splashdown, the ocean is calm. Crew Dragon floats quietly. The mission is complete, but the spacecraft is still working. It checks itself. Power systems remain active. Air stays stable. Computers continue to run. Crew Dragon does not shut down, not yet. Recovery teams reach the capsule. Boats surround it. Engineers watch carefully, because even after landing, danger exists. Fuel remains inside. Pressure systems are active. Everything must be handled slowly. Crew Dragon is lifted from the water. Salt water drips away. The capsule looks burned. Dark marks cover its surface. The heat shield is scarred. This damage is expected. It means the shield worked. To many people, this capsule looks finished. Used, old, but engineers see something else. They see a machine ready to fly again. Crew Dragon is taken to a facility. Here the real work begins. This is not a celebration place. It is a quiet place. Focused. Serious. Every part of Crew Dragon is inspected. Not quickly, not casually, slowly, carefully. Engineers check the heat shield. They measure how much material burned away. They compare it with prediction. If the numbers match, the design is correct. Parachutes are removed. They are studied. Fabric strength is tested. Even small tears matter because parachutes decide life or death. Thrusters are inspected. Fuel lines are checked. Valves are tested. One small leak is unacceptable. Computers are examined. Data is downloaded. Every second of the mission is reviewed. Every decision the spacecraft made is studied. Crew Dragon remembers everything. It records everything. This data is gold. Engineers ask questions. Why did this system activate? Why did that temperature rise? Why did this movement take longer? The spacecraft becomes a teacher. Each mission improves the next one. Old space programs accepted loss. They accepted high cost. They accepted slow progress. SpaceX wanted something different. They wanted learning at high speed. Reusability changes everything. It reduces cost. It reduces time. It increases experience. Flying the same spacecraft again builds trust. Crew Dragon is not rebuilt from zero. It is refreshed, upgraded, improved. Some parts are replaced, some are reused, some are upgraded. Each mission makes the spacecraft better. This approach is not just about money. It is about safety. A flown spacecraft is a proven spacecraft. It has survived launch. It has survived space. It has survived re-entry. Astronauts trust machines with history because history means evidence. Crew Dragon is designed to fly many times. This was planned from day one. Materials were chosen for durability. Systems were designed for repeat use. This is rare in space history. Very rare, but reuse is not only about hardware. It changes how humans think about space. Space travel becomes routine. Not easy, not casual, but normal. Astronauts no longer feel like test subjects. They feel like operators, professionals using a reliable system. This shift is powerful because routine creates confidence, and confidence allows expansion. Crew Dragon is now part of regular missions, crew rotation, research support, emergency return. It is always ready. When docked to the space station, Crew Dragon waits, quietly, patiently. It is a lifeboat. If something goes wrong, it can bring humans home. This responsibility is heavy. Crew Dragon never forgets this role. Systems stay powered, checks continue, even while astronauts sleep. The spacecraft is not alive, but it behaves like something that cares. Reusability also allows fast response. Missions can be planned closer together. Training becomes smoother. Scheduling becomes flexible. This speed matters because the future is coming fast. Crew Dragon is not the final goal. It is a stepping stone. The moon is waiting. Mars is waiting. Longer missions, harder conditions, more risk. Crew Dragon teaches lessons for all of them. Heat protection, life support, automation, human-machine trust. Every success writes a rule. Every failure writes a warning. SpaceX studies both. Crew Dragon also changes partnerships. Private companies work with governments. New ideas meet strict safety. Innovation meets discipline. This balance creates progress. People once doubted this model. They said private spaceflight was dangerous, unreliable, too risky. Crew Dragon answered without words. It answered with results. Mission after mission, safe returns, clean data. The spacecraft became a symbol not of speed, but of control. Control over chaos, control over fire, control over fear. But there is something deeper. Crew Dragon changes how humans see space. Space is no longer far away. It is reachable, repeatable, learnable. This does not make space safe, but it makes it manageable. And that is the difference between dreaming and building. Crew Dragon is built not once, but again and again. The next mission will launch soon. The same capsule, new crew, same trust. When it rises on fire again, it will carry more than people. It will carry experience. In the next part, we look ahead. Beyond Earth orbit, beyond the station, to what Crew Dragon has made possible, because the future is not about one spacecraft. It is about a system, a mindset, a direction. End of part 6. A machine that can return is a machine that can be trusted. To be continued, how Crew Dragon changed space forever. For most of human history, space was a dream. People looked at the sky and imagined. Stars felt far, planets felt unreachable. Space was beautiful, but it was distant. Then rockets came. Humans touched space for the first time, but even then space travel felt rare. Dangerous, expensive, limited. Only a few could go, only sometimes, only with great risk. Crew Dragon changed that story, not suddenly, not loudly, but deeply. Crew Dragon did not just carry astronauts, it carried a new idea. An idea that space travel can be repeated, trusted, improved. Before Crew Dragon, space missions felt like events. Once in a while, big, heavy. Now they feel like operations, planned, regular, controlled. This change is powerful because routine builds confidence, and confidence builds courage. For astronauts, Crew Dragon changed everything. They no longer feel like passengers, they feel like partners. The spacecraft listens. The systems respond. Human and machine work together. Training is different now. Astronauts learn software, they learn screens, they learn systems that think. This prepares them for the future, because future missions will be longer, farther, harder. Crew Dragon also changed how missions are planned. Launch dates became flexible, capsules became reusable, delays became manageable, space stopped feeling fragile, not safe, but stable. This stability matters, because research needs time. Science needs consistency. Experiments on the space station now continue smoothly. Crew rotations are reliable, supplies arrive on schedule. Crew Dragon made the station feel permanent, not temporary, but the biggest change happened on Earth. Inside human thinking, people stopped asking, can we go to space? They started asking, how often can we go? This question changes everything. New generations watch launches. They see astronauts return. They see the same spacecraft fly again. Space becomes familiar, not normal, but understandable. Crew Dragon made space visible again, not as mystery, but as system. This matters for inspiration. Young minds see possibility, not fantasy. Engineers study Crew Dragon, they learn from its design, they copy its ideas. Automation, redundancy, human-centered design, other spacecraft improve. Other companies innovate, competition grows. This is healthy, because space grows with challenge. Crew Dragon also changed partnerships. Governments trust private companies. Private companies respect strict safety. This balance was difficult, but it worked. Trust was earned. Mission by mission, Crew Dragon did not rush. It proved itself again and again. The moon is watching. Future missions will go there. Crew Dragon may not land on the moon, but its lessons will. Life support systems, heat protection, re-entry control, human-machine trust. Mars is even farther. Months of travel, isolation, radiation. Crew Dragon is not designed for Mars, but it teaches how to design for Mars. Reliability matters more than speed, automation matters more than power, psychology matters as much as engineering. Crew Dragon showed that humans need calm machines, machines that reduce stress, machines that support life silently. This idea will shape future spacecraft. There is also a deeper meaning. Crew Dragon proves humans can build systems that survive fire, that survive failure, that learn. This is not just space technology. This is human progress. Crew Dragon also changed public trust. People once feared spaceflight. Accidents were remembered. Loss was painful. Crew Dragon brought confidence back. Slowly, carefully, safe landings, clear communication, visible improvement. People began to watch launches with hope, not fear. This trust is fragile, but it exists. Crew Dragon did not promise perfection, it promised preparation, and it delivered. Space is still dangerous, always will be, but danger can be managed. Crew Dragon does not defeat space, it respects it. That respect is its greatest strength. As missions continue, Crew Dragon becomes familiar, not boring, but known. This familiarity allows planning, long-term planning, permanent space station, lunar bases, deep space missions. All need reliable transport. Crew Dragon is the first step. It is a bridge between Earth and beyond. One day humans will travel farther, they will look back, they will remember the moment space became routine. Crew Dragon will be part of that memory, not as the biggest spacecraft, not as the fastest, but as the one that made space repeatable. Repeatable means learnable, learnable means expandable. That is how civilizations grow, but the story is not finished yet. One final question remains. What happens when everything fails, when systems break, when humans must escape? Crew Dragon was built for that moment too. In the final part, we face the ultimate test, emergency, failure, survival, because true safety is proven not in success but in crisis. End of Part 7. Space did not become easier, humans became smarter. To be continued. The ultimate test of Crew Dragon's space is silent, but silence does not mean safety. In space, danger does not warn, it does not knock, it arrives suddenly. Crew Dragon was built for this moment, not for perfect days, but for the worst one. Every spacecraft can fly when everything works. Only a few can save lives when everything fails. From the first design, SpaceX asked a hard question. What if something goes wrong? Not if, but when. What if the rocket explodes? What if engines fail? What if computers stop? What if humans have only seconds? Crew Dragon exists because of these questions. During launch, danger is everywhere. Millions of parts move at once. Fuel burns violently, pressure rises. One small mistake can destroy everything. In the past, astronauts had no escape. If the rocket failed, there was no way out. Crew Dragon changed this. At the top of the rocket, Crew Dragon sits quietly, but it is ready, always ready. Hidden inside are SuperDraco engines. They are not for travel. They are not for comfort. They are for survival. If sensors detect danger, Crew Dragon does not wait. It does not ask permission. It reacts. In a fraction of a second, the SuperDraco engines fire, powerful, violent, precise. The capsule is pulled away from the rocket, fast, very fast. This is called a launch escape system. It is the last line of defense. To prove the system works, SpaceX did something brave. They tested it, for real. A rocket launched. Everything looked normal. Then suddenly the rocket failed, on purpose. In that moment, Crew Dragon had to decide, not humans, not engineers, the spacecraft. Sensors detected the failure. The escape system activated. SuperDraco engines ignited. Crew Dragon tore itself away from a dying rocket. Fire surrounded it, debris flew everywhere. For a moment it looked impossible. Then the capsule survived. It flew away safely. Parachutes opened. It landed in the ocean. No humans were inside, but lives were saved in theory, and theory became proof. Crew Dragon passed the ultimate test, but danger does not end after launch. Space itself is hostile. What if pressure drops? What if a small hole appears in space? A tiny leak can be deadly. Crew Dragon monitors air constantly. If pressure changes, alarms sound. Sections conceal, time is bought, life is protected. What if power fails? Crew Dragon has backup batteries. Then backup to backup. Power loss does not mean darkness. What if computers crash? Crew Dragon uses multiple computers. They vote, they check each other. If one lies, others correct it. No single failure can destroy the system. This is called fault tolerance. Crew Dragon was built around it. Even fire inside the capsule was considered. Materials resist flame. Sensors detect heat. Fire is rare, but planned for. What about re-entry? The most violent part of the mission. If the heat shield fails, there is no escape. So Crew Dragon's shield is over-designed, tested beyond limits, burned on purpose. What if parachutes fail? Crew Dragon uses multiple parachutes. Not one, not two, four. If one fails, others compensate. Redundancy saves lives. Every system follows the same rule, no single point of failure. But the most important safety system is trust. Trust between humans and machine. Astronauts train for emergencies, but they hope to never use them. They know Crew Dragon is watching, even when they sleep. This constant protection changes psychology. Fear becomes focus, panic becomes preparation. Crew Dragon does not promise safety, it promises response. In space, that promise matters. There have been moments when weather was bad, moments when systems were questioned. Missions were delayed, not rushed. Crew Dragon taught patience, because rushing kills. This culture shift is important. Spaceflight is no longer about bravery alone. It is about discipline. Crew Dragon is honest. If something is wrong, it does not hide it, it delays, it waits. This honesty saves lives. Some people say machines should not decide life and death, but in space, speed matters. Milliseconds matter. Crew Dragon can react faster than humans, and that saves lives. This does not remove humans, it protects them. Crew Dragon was built with respect for life, not for records. Not for speed. Every mission proves this philosophy. Humans have faced tragedy in space before. Loss changed rules. Pain wrote lessons. Crew Dragon carries those lessons. Quietly, seriously, it remembers the past so the future can be safer. In the end, Crew Dragon is more than a spacecraft. It is a promise that humans will not accept unnecessary loss, a promise that technology can protect, a promise that learning never stops. Space will always be dangerous. That will never change, but how humans face danger has changed. Crew Dragon does not conquer space, it negotiates with it, and that is why it works. One day, new spacecraft will replace Crew Dragon, better ones, stronger ones, but they will all carry its DNA. Automation, redundancy, human-centered design. Crew Dragon will be remembered not for how fast it flew, but for how safely it brought people home. The desperate call was answered, not with words, but with design. From fear to trust, from risk to routine, from dream to system. This is how progress happens. This is Crew Dragon.